Okay, so let's get right into the hidden plumbing of today's AI agents. We all crave that magical split-second response, right? But what does it really take to build an AI that's not just ridiculously fast, but also perfectly safe and reliable? It's this constant tug of war between raw speed and strict logical order. And today, we're going to look at exactly how engineers pull it off.
And that really is the central question, isn't it? How can an AI possibly juggle dozens of actions at once to give you that feeling of instant gratification, while at the same time making absolutely sure that the most critical steps happen in a very specific, unbreakable order? It's a real battle between what we, the users, demand, which is speed, and what the system needs, which is total safety and logic.
All right, so here's how we're going to break this down. First, we'll dive into what I call the parallel magic show. That's the secret to its speed. Then, we'll look at the sequential safety net, which is what stops the whole thing from descending into chaos. After that, we'll see how the system's brains classify tasks, how it manages stress, and then we'll get to the really cool part, its incredible self-correcting workflow.
So, first up, the magic. Imagine asking an AI to plan a trip for you. You don't want to sit there and wait as it checks one airline and then the next and then a hotel. No way. You want all the options, like, right now. Well, that feeling of instant results comes from a really powerful engineering concept: parallel process. Think of it like turning on a dozen faucets all at once. During this search and discovery phase, the agent is doing a whole bunch of independent things simultaneously. It's hitting up different airlines, checking hotel chains, pulling down weather forecasts, and even monitoring for price drops, all at the exact same time. The key is none of these tasks depend on each other, so they can all run in parallel.
So yeah, this parallel approach is absolutely essential for that powerful, snappy feeling. It's how the agent can tear through mountains of data and get back to you in seconds. But, and this is the big but, raw speed isn't the whole story. For some tasks, doing things all at once would be a complete and utter disaster.
And this brings us to the total opposite pressure: tasks where the order of operations is everything. This is what we call the sequential safety net. It's the system's guarantee that the supercritical stuff happens in exactly the right sequence. Because, getting it wrong would be catastrophic.
The perfect example of this is processing a payment. It's a totally rigid, unchangeable chain of dominoes. First, you have to verify that the funds are actually available. Only then can you process the payment. And only after that payment goes through can you confirm the bookings. And finally, you send out the confirmation. Every single step is 100% dependent on the one that came right before it.
This really highlights what you could call the flight before hotel problem. It's just pure, simple logic. You cannot book a hotel for a trip that isn't even confirmed yet. You can't charge a credit card for a flight that might not be available. These sequential tasks are like the safety rails on a roller coaster. They prevent massive, costly, logical error.
So, we've got these two forces pushing against each other: the need for parallel speed and the absolute demand for sequential safety. Now, the really clever part is how the system actually resolves this conflict. It uses this sophisticated optimization layer that acts as the brains of the whole operation.
Before a single thing happens, the agent looks at the entire list of jobs it has to do. It scans for dependencies. If a task, like check the weather, doesn't depend on anything else, boom, it gets thrown into the parallel queue to be run alongside all the other independent stuff. But if a task, like process payment, absolutely depends on a previous step, it goes straight into the sequential queue. This sorting logic is the secret sauce to getting both speed and safety.
Now, a truly great agent doesn't just blindly execute tasks. It has to manage itself. There's this constant, invisible work happening behind the scenes to monitor the system's own health and its resources, especially when things get stressful.
The system is basically taking its own pulse, constantly. It's watching its own CPU usage, sure, but it's also watching external things. For example, it keeps a close eye on API rate limits. Think of that as a speed limit that an airline server puts on you. If you make too many requests, too fast, they just cut you off. By monitoring all of this, the agent keeps itself and its partners from getting overwhelmed.
And what happens when it does start to get overwhelmed? It uses this brilliant mechanism called back pressure. Honestly, it's just the system's elegant way of putting its hand up and saying, "Whoa, hold on, I'm at full capacity. Let's just slow down the flow of new jobs until I can catch my breath." It's a self-preservation instinct that prevents the whole thing from crashing and burning.
And all of this brings us to the true engineering elegance of these systems. They aren't just dumbly following a static plan. They're dynamic, they're self-correcting. You could almost think of them as living organisms that adapt their own workflow in real time.
So if the system spots a bottleneck, let's say a hotel's booking website is suddenly running super slow, it doesn't just grind to a halt. It intelligently reroutes its own efforts. It might start prioritizing other parallel tasks, or shift resources around to compensate. This is way beyond just following a script. This is active, real-time problem solving, and that's the mark of a truly intelligent agent.
So, if there's one thing to take away from all this, it's this. The real magic of an advanced AI agent isn't just its raw speed. It's this incredibly smart, self-regulating brain. It's the system's ability to look at itself, understand the jobs it needs to do, and constantly recalculate the fastest and, most importantly, the safest path to get everything done. And that leaves us with a final question to chew on. This elegant balance between moving fast in parallel and staying safe in sequence, it's a fundamental design pattern. We've talked about it in an AI travel agent, but where else is this absolutely critical? I mean, think about managing a global supply chain, or executing high-frequency financial trades, or even orchestrating a massive genetic sequencing project. How many other parts of our world depend on this exact same delicate dance between speed and safety?